Hello everyone, I'm reading portions from my new book, Intense Design, and what I want to look at now is some of the design guides that are offered in chapter 17. And I'm not going to read this straight away because it's a little, shall we say, dry. But anyway, there's a variety of design guides that are included in this book. And with some humility, there are better design guides available from vendors, and I rely upon them. But what I have in here are things that wouldn't show up necessarily in their book. So if you're designing a bearing, don't read my book, read Torrington's book or someone else. But anyway, there's kind of discussion about the importance of design guides, but then what I do is I give some information on overall issues related to strength, heat transfer, and fluid dynamics. There's just a real brief outline of those, some principal issues in connection with those. However, I have a whole book that relates to that sort of thing. So if you're a designer and you want to understand engineering principles that guide design, take a look at my other book on engineering. You might find that really helpful. But then I have a section here on design for manufacturing, and in there I talk about some rules of thumb for different things. So rules of thumb are meant to be broken. These heuristics are guided by experience, by other people's experience largely. So I've got a section on injection molding, about maintaining wall thicknesses and draft angles and stiffening panels and all that sort of thing. On injection molding, which is really important now, it's okay to look at other injection molded parts and see how other people did things. That's okay. And for some of you that are interested in purely concept, this might seem dry, but you want to be literate about the manufacturing techniques involved with your design because they're really important. But anyway, there's a brief section on injection molding, die casting, stamp metals. Sorry, I'm outside of my backyard and I have creatures making strange noises. Fasteners. And then I have a very brief summation of design for assembly tips. Just a few things, kind of common sense, but they're well established. Then I have a section on dimensions and tolerances, which is something that sounds dry but are very important. Dimensions obviously are part of what describe your design. And of course, if you design something, you need dimensions, you need the relationship between dimensions, and geometric dimension and tolerancing is really helpful for that. We're looking at perpendicularity and geometric relations of dimensions, but you also want surface finishes, to fully spec out a part. And I describe that in here. But two, you need tolerances. There's default tolerances, but the tighter the tolerance, the more expensive the part and the more scrap rate, therefore the more ecological impact and other sort of things that arise. So I have actually default tolerances that I've used that are helpful because you need to have some sense for what the maximum minimum dimension can be. And it's important. You can get some good information on that. But it differs, even though these rules of thumb or on tolerances or these guidance, they differ completely in two places. I put this little caveat. Remember that these are not engineered values and can never replace values developed by engineering analysis, dimensional stack-ups, failure mode and effects analysis, or other mitigating considerations. But anyway, I even have things, old-fashioned things on gear centers and stuff like that that could be very helpful for you. Thread specs, ABEC specs, all that kind of stuff, so you can sit at the table. And when people might say, well, what kind of bearings are you going to use, or what kind of thread form are you going to use? You've got some information on it. That's good information. And then I have a section on material selection, which is a big issue. There's so many materials out there. What do you pick? So I list my favorites and a place to start, and that's kind of what it comes down to. You get a palette of materials that you like and that you're familiar with, and that's fine. But there's so many things you can do with materials, and there's so many heroic elements in materials and material finishes that come into play. I've had things saved by fluorinated grease, which doesn't dissolve in hydrocarbons, so it can save the day. Molybdenum disulfide, surface treatments, Teflon, thin dense chrome, all that sort of thing are really, really helpful. But I have favorites for. I list ceramics, glasses, steels, aluminums, brasses, nickel alloys even. I have my favorites for different sort of things. And of course, with 3D printing, you have a lot of favorites connected with that as well. I have a brief section on ergonomics, including the 4 rules of ergonomics, which I will read right here, which are: keep the body in the neutral position, accommodate people's different dimensions, recognize strength and dexterity are reduced with arm extension and rotation, and reduce repetitive motions. Those 4 principles are really what guide ergonomics. It sounds simple, but that's it. People want to be in the neutral position as if they're floating in a hot tub. People are different sizes, and you need to recognize that. And then when you reach and twist, you no longer have the dexterity or the strength you would otherwise. And there's information on all this, anthropometric data on human dimensions, the degradation of strength and dexterity with reach. And then you want to reduce repetitive motions, which is a cause of things like carpal tunnel syndrome. Okay, and then I have some other, I have some multipliers for figuring out shoulder heights, waist height, knee height, eye height based on a user's height. Then I have a little thing on mapping, some thoughts on design software, some visual design principles, color, proportion, rhythm, and so on. So that's in the design guide section. It's short-ish, but I hope that you find it very helpful. Thank you.